It's late. You're lying in bed, thumbs scrolling, and everyone seems to be doing better than you. This one's at a rooftop party packed with people who clearly adore them. That one's tagged in 3 group photos before lunch. Your old classmate has a wedding, a reunion, a whole crowd that shows up, and you think the quiet thought almost nobody says out loud. How does everyone have more friends than me? Here's the strange part. You're not imagining it. On average, your friends really do have more friends than you do. And it's not bad luck, and it's not because you're boring. It's a piece of mathematics so stubborn, it's almost a law of nature. It even has a name, the friendship paradox. By the end of this, you'll see why almost everyone feels less popular than their friends, and why almost everyone is statistically right. Now, your first instinct is to call this nonsense, and honestly, good instinct. Because friendship is a two-way street. If Maya is friends with Leo, then Leo is friends with Maya. It's mutual every time. So it feels like it all has to even out. For every person who has fewer friends than their friends, shouldn't there be someone on the other side with more? It sounds like saying everyone is below average, which is impossible. That's the trap. It feels airtight. But your friends have more friends than you is not the same claim as everyone is below average. Those are 2 different sentences, and the gap between them is the whole story. Let's find out where our gut quietly cheats. Let's not argue with words. Let's build the smallest town that can settle this. 5 people who all know each other to different degrees. Maya is the social hub. She's connected to almost everyone. Anna is well-liked, knows most of the group. Leo and Sam each have a couple of friends. And Ben knows exactly one person in town. The diagram on screen shows every friendship as a line, and each person's friend count beside them. Now here's your question, before any arithmetic. We're going to compute 2 averages. First, the plain average friend count if we ask each town's person, how many friends do you have? Second, the average friend count of the friends, every friendship looked at from both ends. Will those 2 averages come out equal? And if they're different, which one is bigger, the people or the friends? Lock in your guess. Equal, people win or friends win. Then we'll count it together out loud. First average, the simple one. We walk up to each of the 5 and ask, how many friends? Maya, the hub, has the most. She's tied to nearly the whole town. Anna's right behind her, friends with most of the group. Leo and Sam each have a small handful. And Ben has just the one. Add those 5 friend counts together and divide by 5 people. The screen does the sum, and it lands on 2.4. So the typical person in this town has about 2.5 friends. That's the true, fair average. Remember that number, 2.4. That's the how popular is a normal person here number. Now for the sneaky one. For the second average, we don't sample people. We sample friendships. We walk along every line in the diagram and, at each end, ask that friend their count. Think of it as, pick a random person, then ask about a random friend of theirs. And here's the subtle thing. Popular people get asked about a lot. Maya, the hub, sits at the end of many friendships, so her big count gets counted many times. Ben, with his single friendship, gets counted exactly once. So when we average over friendships instead of people, the popular folks show up again and again, and the loners barely show up at all. We total every friend count, each one weighted by how many friendships it sits on, divide by the total number of friendship ends in town, and it lands on 2.83. 2.83, higher than 2.4, every single time for this town. So, the answer to your earlier guess, they are not equal, and it's the friends that win. The average person here has 2.4 friends, but the average friend has 2.83. Same town, same people, same friendships, 2 honest averages, and they disagree. And notice nobody lied and nothing was rigged. We just asked the question 2 different ways and got 2 different numbers. If you guessed friends win, nice, you've already outthought most of the internet. But why does it tilt that way and not the other? Let's name a cheat. Here's the mechanism, and once you see it, you can't unsee it. When you pick a person at random, everyone has an equal shot. Maya, Ben, all the same. But when you arrive at someone by following a friendship, by being their friend, you're far more likely to land on a popular person. Because a popular person is attached to many friendships. They're on lots of lists. A lonely person is on almost no lists. There's barely any path that leads to them. So a random friend is not a random person. It's a random person biased toward the popular, because popularity is exactly what puts you on more lists. Your friends, by definition, are people who have at least one friend you. And the more friends someone has, the more likely they are to be your friend in the first place. That's the quiet cheat. Friendship doesn't sample people evenly. It samples them by popularity. Mathematicians have an exact handle on this, and it's beautiful. Call the average number of friends a person has the mean degree. That's our 2.4. Then the average number of friends that a randomly chosen friend has equals that mean plus one extra term, the variance of the friend counts, divided by the mean. In plain words, the friend's average is the people's average plus a bonus. And that bonus is built entirely out of how much friend counts vary. This is the punchline. That bonus term can never be negative. Variance is a measure of spread, and spread is never less than 0. So the average friend is always at least as popular as the average person. Always. It's not bad luck. And there's exactly one way the gap disappears. If everyone in town had the exact same number of friends, 0 variation, perfectly equal, then the variance is 0, the bonus vanishes, and the two averages finally tie. But the moment friend counts vary even a little, and in real life they vary a lot, your friends win. Structurally. Guaranteed. Now, go back to that phone in the dark. Your social feed is built almost entirely out of friends, people you followed. And following is exactly that biased sample. You overwhelmingly follow the popular, the loud, the active. The quiet person with 11 followers and 1 post a year, you probably never see them. So your feed is a room packed with the most connected, most active people you could find. Of course, they look like they have more friends than you. On average, they do. Of course, they seem to travel more, post more, get invited to more. You handpicked the high-degree people. The feeling isn't a glitch in you. It's the friendship paradox running every time you open the app. And it generalizes almost rudely. On average, your followers are followed by more people than you are. On average, the people at the gym are fitter than the average person. You only see the ones who show up. Even, famously, on average, your romantic partners have had more partners than you. Same bias, every time. You're sampling along the connections, not across the whole population. Here's where the paradox stops being a sad bedtime feeling and starts saving lives. Suppose a new disease is spreading and you want early warning. You can't watch everyone. So who do you watch? Watching random people is slow. Most random people are not very connected, so the outbreak reaches them late. But the paradox hands you a free trick. Pick random people, and then ask each of them to name a friend. Watch the friends. Because of the bias we just proved, those friends are more connected, more central, more in the thick of things. So they tend to catch the disease earlier than the random crowd does. Researchers have actually done this on a real flu outbreak. The friend group lit up with infections days ahead of the random group, a built-in early warning system. No map of the whole network needed. No knowing who's important. Just name a friend, and the math quietly points you at the well-connected people. The same bias that makes your feed feel lonely can be turned around to spot a wave before it crests. So here's the whole thing in one breath. Your friends have more friends than you, and so do almost everyone's. Because a friend is never a random person. A friend is someone popularity made more likely to know you. Sample along the connections, and you always tilt toward the well-connected. It's not a flaw in your life. It's a feature of how networks are shaped. So the next time a feed makes you feel small, you can smile a little. Everyone scrolling feels exactly the same thing for exactly the same mathematical reason. And here's your homework, the fun kind. Where else is this bias quietly fooling you? The class you took where everyone seemed smarter than you? The flights that always feel more crowded than the airline's average load? The waiting room that's somehow always full? Drop the sneakiest one you can think of in the comments. The place where the average you experience is secretly the popular average. I'll see you in the next one.